Hi everyone, today we are going to solve one of the questions from function topics. So this is from part B and paper 1 question. So let's start. We have a f of x function which is defined as kx minus 5 over x minus k. And in the first part, we want to find out vertical asymptote. In my previous video, you know that to get the vertical asymptote, we should make the denominator as 0. So what was my denominator? X minus k equal to 0. So in that case, I will get x equal to k. So my vertical asymptote is x equal to k, which is 1 mark. Second question is saying, what's the horizontal asymptote? Okay, so let's try this one. To get the horizontal asymptote, we are looking for, the first thing we should check is the degree of the rational function in this case. So degree, let's write this function again, kx minus 5 over x minus k. And so what is the highest degree? In this case, it's 1, right? And here it's also 1. At this stage, we need to check the leading coefficient of the highest degree for the numerator and for the denominator. So in this case, for the first one, degree of denominator and degree of numerator. So let's say the first one is degree of numerator, which is 1, and the leading coefficient is k. So it will be k. Okay, how about degree for the denominator? The leading coefficient is 1. So it's just 1. And you divide both of, you need to check the ratio between them. So the ratio, which is k over 1, which is k. And so my horizontal asymptote will be y equal to 0, k. Y equal to k. X equal to k for the vertical, y equal to k for the horizontal. Now, let's look at the third question. Use the algebraic method to determine whether f is a self-inverse. Okay, to get the self-inverse, let's clear this all. So the self-inverse means if you take the f of x and its inverse, if they are same, then we call this function as self-inverse function. So we need to show this. If you could make it, then it will be, so f will be self-inverse. So this is what I'm planning to do. So I have f of x. Now I need to get the inverse of f of x. So let's start. So the basic way is make this equal to y, kx minus 5, which is my f function, equal x minus k. So I will make it equal to y. Okay, equal to y. And then I will get x in terms of y. Okay, so let's see. Kx minus 5 equal to xy minus ky. So let's move this to the left. Then it will be kx minus xy equal to, and I'm going to move -5 to the right side, which will be +5 equal to 5 minus ky. So now let's factorize this section. So if I move x outside, I'll get k minus y equal to 5 minus ky. Now, if I divide each side by k minus 5, I will be able to get x in terms of y. So k minus y to the left, And I'll do the same thing in the right side, k minus 5. So then x will be k minus 5 and numerator section will be 5 minus ky. This one and this one will cancel. I will get x in the left, and in the right side I have this one over here. So last thing, when we express this as an inverse of x, we just need to change y with x. Just replace y with x. This will be 5 minus kx over k minus x. So now let's see. Do we have the same function here? What was my f of x? Let's see my f of x. If they are the same, then f is a self-inverse function. So f of x function is defined as kx minus 5 over x minus k. As you see, both of them, x minus k, yeah, both of them are the same. If you just make this in this form, so I'll put negative sign in front of it, kx plus 5 minus 5 okay, over, and I'll put minus here as well. It will be negative x. So negative x will be x minus k. So as you see, if I put negative sign in front of numerator and denominator at the same time, actually I don't change anything. So negative and negative will cancel each other. I will get x minus k. Here in the top, I'll get kx minus 5. Okay, so negative and negative will cancel each other. I will get kx minus 5 over x minus k, which is the same as f of x. So f inverse is the same as f of x. So it is self-inverse. Okay. So next question is sketching part. So sketch the graph y equal to f of x, stating clearly the equation of any asymptote, coordinates of any points of intersection with coordinate axis. Okay, so first of all, we have to replace k with 3 because in this case, it's a consider when k equal to 3. So if I consider this as 3, k will be 3, then my function will be like this. So 3x minus 5 over x minus 3. That's my f of x function. Now let's get the y-intercept. So to get the y-intercept, as you know from the previous videos, to get the y-intercept, x equal to 0, x must be 0. If x equal to 0, what happened? 3 times 0 minus 5 over 0 minus 3. So minus 5 over minus 3 will give me 5 over 3. So y equal to 5 over 3. But we should always write this as a coordinate. So my x is, when my x equal to 0, my y will be 5 over 3. Now, y-intercept is done. Now let's try to get the x-intercept. And when we try to get x-intercept, y equal to 0 this time. So y is the same as f of x. So as it is in terms of x, it called as f of x, but we can consider f of x as y. So my y equal to 3x minus 5 over x minus 3. So if y equal to 0, then that will be 0 equal to x minus 3, 3x minus 5. Cross multiply them. 0 times x minus 3 will be 0. So from here, I'll get 0 equal to 3x minus 5. Move negative 5 to the right, to the left. It will be, x will be 5 over 3. Yes, 5 over 3. So then, using all this information, I can conclude that my second point is 5 over 3, comma 0. Okay. Now, once we get this, the next part is to draw the diagram or sketching this. Let's do it. Okay, so first of all, we have vertical asymptote from the previous question, which was, as you remember, it was x equal to k. Now k is equal to 3, so vertical asymptote is x equal to 3. Okay, and horizontal asymptote, we get this as k, which is also 3, because k is defined as 3 here over there. So y equal to 3 for the horizontal one. It means I cannot touch these points. So basically, first draw this. So y x equal to 3. Let's say this is my 3. So these are my borders. Okay, and we have horizontal asymptote, which is also 3. So my sketching line won't touch them. Okay, so these are my border. Okay, and the next thing is to put the x-intercept and y-intercept. So what was my x, like I have 2 points, right? 0 and 5 over 3, and 5 over 3 and 0. So x equal to 0, y equal to 5 over 3. So let's say this is my point. This is 0 and 5 over 3. Okay, and 5 over 3 to 0. So let's say this is 5 over 3. This point over here is 5 over 3. So my line should pass through this 2 point. Okay, so it will be something like this. Or like this. Without touching their vertical asymptote. Goes like this. And the other one will be symmetrical. Like this. Okay. And so that's it. So the most important thing in this question is to show the x-intercept and y-intercept. As you see, I show both of them and the borders. Look here. My line doesn't touch any of these dashed lines. So that's it for part D. Now let's look at for part E. Okay. Now, the region bounded by the x-axis, y equal to f of x, and the lines 5, x equal to 5 and x equal to 7, rotated through 2 pi about x-axis. So here I have a formula before I start recording. I put this formula from the formula booklet. So here, when we rotate about the x-axis, I'm going to use the first formula. Okay, so he wants me to find out the volume. Okay, let's try. So I have f of x function. So we can always move pi outside of the integral. So pi, and I have my borders, which is given in this question, 7 to 5. Okay, what? So what is my y? 3x minus 5 over x minus k, which is x minus 3 square. Okay, dx. Okay, let's start. So we should solve this integral, and this is paper 1 question. So for that reason, we are not able to use TI or any other GTC. So let's think what we can do in this case. How about if we call u as x minus 3? Because the leading coefficient for the numerator is 3 and leading coefficient of denominator is 1, but most important thing is the degree are all the same. So we can say just x minus 3 equal to u, and we will express everything in terms of u. So then dx, if we take the derivative from left, I'll get 1 dx equal to du, right? But we need to do something else. So how about if we express x in terms of u? So x equal to u plus 3. Because I need to define 3x minus 5 in terms of u. So then 3x minus 5 will be 3 times u plus 3 minus 5, which will be 3u plus 9 minus 5 will be 3u plus 4. Okay, so now instead of 3x minus 5, let's replace this with 3u. Okay, integral. We have pi outside from 7 to 5 in bracket. So 3x minus 5 is 3u plus 4. As you see, everything is in terms of u. And x minus 3 is u, right? Square over here, du. Why du? Because dx equal to du. So instead of dx, I'll just put du. So here this is 4. Now pi times, again, let's move pi, always keep this out, always outside. So 7, 5. So what is 3u over u? It will be 3 plus 4 over u will be 4 over u. And write like this, square. Okay, so let's remember a plus b squared is the same as a squared plus 2ab plus b squared. So I use this to solve this question. A squared plus 2ab plus b squared. And so as you see here, my a is 3 and b is 4 over u. And integral, again, pi, right, from okay. From here, be careful, because once I change u with x, because these intervals are for x's, right? So when x equal to 7, how about what happened to u? So we need to change them. We don't have 7 and 4 anymore. I mean 7 and 5. I was going to say that in the end, but let's just do it now. So when x equal to 7, because this is my intervals, right? X equal to 7, u will be 4. And when x equal to 5, u will be 2. So my interval is from 4 to 2. 4 to 2, 4 to 2. Here we have also 4 to 2. Okay, take a square for 3, that will be 9 plus 2 times 3 times 4, 624 over u, right? Plus b square. What is my b? It's 4 over u, so b square will be 16 over u square. Okay, du. That's it. Now it's straightforward to solve this integral because I have everything I need. And so in this case, that will be, let's just do this way. So let's change the color. Okay, then that will be pi. So look, you can do this way, like from 4 to 2, it will be 9u, right? Because just to recall, 9 du is the same as 9u, right? 9 is the constant number. Move this to the outside of the integral. D and integral sign will cancel each other. We get du, u. So plus 24. Okay, let's try this one. 24 over u is, we can just move 24 outside. Let's say this is du. Du over u is ln u. Okay, so 24 ln u. And what else? The last one. 24 ln u. And the last one is 16. Can we express this as u negative 2 du? Yes, we can. And 16 move outside of the integral. So u negative 2 du will be u negative 1 over negative 1, which will be negative 16 1 over u. So 16 over u. Okay. And then what's my intervals from 4 to 2? So that will be pi times. So 9 times 4 will be 36 plus 24 ln 4 minus 16 over u, which will be 4. Okay, minus, let's open a bracket. So if we put 2 into 9u, that will be 18. Okay, plus 24 ln 2 minus 16 over 2, which is 8. Okay, so then I have still pi outside of my bracket. So 36 minus and minus becomes plus. Here it will be 32 and ln u. Okay, let's add the integer number first. So 36 I have here, so minus 4, which will be 32, minus 18 plus 8. Yeah, so it will be 32 over here, 32 minus 18. Let's do it. 14 plus 8 is 22. So this section is 22. Just check this. Negative 18, negative 4, and plus 8. Why plus 8? Because minus and minus become plus. So that will be plus 8. 22 and for that one, 24 ln 4 minus 24 ln 2. So let's do it here. 24 ln 4 can be written as ln, because here it say express this in terms of ln 2. So 4 can be written as 2 power of 2, right? And this 2 can move as a coefficient of ln, which is going to be 48 ln 2, okay, minus 24 ln 2, which will be plus 24 ln 2. That's it. So pi times 22 plus 24 ln 2. That's it. Okay, that's it. It's a long question, which has a 9, 10, 15 marks from part B. So that's how we solve it. If you have any question, please write on the comment section. Okay, thank you for watching.